Hey guys, Mr. Barnes here, and bringing you my second video of this course, which is section 2.1 or sorry 1.2 Arithmetic Series, and it leads in from section 1.1 Arithmetic Sequences. If you haven't watched that video, I'd recommend watching that video first, and then watching this video. So again, a lot of people in class are sort of confused between the difference between a sequence and a series. Well, to tell you the truth, they're really closely related, and you can't have one without the other. All a series is taking the terms of a sequence, T1, T2, and T3, and then so on and so forth until we get to the last term, T of n, and simply adding them together. So you add T1 plus T2 plus T3 plus so on and so forth until you get to Tn. And you get a number. You're adding a set number of terms or a finite number of terms together to get a number. So let's have a look at how we actually add them together and how we find the formula. Because you can imagine if this is T100 or even T20, it's going to take you a significant amount of time to be able to add those together. So there is an easy way of doing it, and it's a formula. We discussed it in class. So defining the sum of the arithmetic series is given to you by S of n. So you see S is the sum, n would be the number of terms. So you might have S7. So that's the sum of the first 7 terms. Where n is a number of terms divided by 2, first term plus the general term or the nth term, t of n sometimes referred to as the last term, and we also knew t of n is equal to t1 first term plus d of n minus 1. That's very useful sometimes. And remember that t of n is just t, if say if n is 7, that's just t7, so it's the last term of the series. So sometimes it helps to think of the formula like this. So S of n, or S of the number of terms, the sum of the first n terms, is equal to n divided by 2, first term plus the last term. So a really easy way to remember it. Some people write it with this t of n replaced by this. And you know, that's okay, that works perfect. But there's a place for that. There's definitely a time and a place for that. And I think you can always adjust the problem. I think it's easier to think of it like this first, or like this, and then adjust to the problem that's coming your way. Because not all problems will need the most complicated form, which is this with that already subbed in. Some will, but when we get to those, you can deal with it then. Alright, let's see an example. So this one's a very straightforward example. It says find the sum of the series 2 plus 4 plus 6 plus ... until you get to 37. Let me adjust this a little bit here. Put another plus sign there. So until you get to 36, sorry. So let's see what we have. So we have the first term T1, which is 2. We have the last term Tn, which is equal to 36. Now we don't know what particular number of the sequence this is, or of the series. And we also have, now you could probably think about it and find out, but we'll find it systematically. We don't have n. So what we can do is we can sort of treat this like a sequence and find the general term right away. So if we look here this is my sequence. So let's find the general term of this, and we can find our common difference, which is 2, of course. It's going up by 2. So t of n is equal to t1 plus d of n minus 1. So t1 is this guy, 2. And d is, of course, also 2. N minus 1. So we're going to distribute through here. So we're going to have 2 plus 2n minus 2. So we got t of n. And t of n is going to be equal to, these guys are going to cancel out, 2n. So there's my general term for that sequence. Now we can use that general term to be able to find how many terms we actually have in the sequence. So the number of terms we actually have, well, t of n is equal to 36. So 36 is equal to 2n, or n is equal to 18. So we have 18 terms in this particular sequence. So let's go down and work out what's the sum of our series. So let's remember our formula. So S of 7, or sorry, S of 18. I was thinking about what I was talking about there in the intro. So S of 18, 18 being the number of terms, and then the number of terms, 18 divided by 2, times the first term, t1, plus the last term. Well, the last term is t of 18, which we know is 36. So 18 divided by 2 is 9. The first term is 2, the last term is 36. And then we're going to have 9 times 38, and then let's check that. 9 times 38, 342. So the sum of the first 18 terms of this particular series, this particular sequence, given by t of n is equal to 2n, is 342. So that's what that series adds to. And you define the same thing if you literally punched in your calculator 2 plus 4 plus 6 plus 8 plus 10 until you got to 36. You'd find that same number. So that's what this formula gives you. That's the usefulness of it. Let's look at a slightly different example, maybe a little harder example. So this one's asking us to find t1, and we're giving the difference d is equal to -6, s of n is equal to 32, and n is equal to 13. So that s of n equal to 32 is essentially s13, because that's n. So let's fill out our formula and see what we have in it. So we have s of 32 is equal to 13 divided by 2, t1 plus t of 13. Okay, so I know what this is. This is 13. Now the question is, what is t of 13? Well, I don't know what the first term is, so I have no way of being able to work out that. So let's see if we can replace this t of 13 with something different. Well, I know that t of n is equal to t1 plus d of n minus 1. Well, t of 13, so 13 is equal to t1. Well, I don't know what that is, but I know that d is -6, so -6. Then n minus 1, well, n is 13, so 12, just like that. So essentially, I have t1 minus 72 for t of 13. Just like that. So I can take this part and sub it in here. So plus t1 minus 72. And see, I essentially now I've created an equation with only one unknown, which is t1. So we can use that to solve. So let's see what we have here. So let's reduce this down inside here first. So 13 is equal to 13 over 2. That's not 13, that's 32. Oh, I see what I did here. Rookie mistake. Sorry guys, it's a long weekend. I'm giving up. I'm still full on turkey here, so mistakes are bound to happen. Here we go. So yeah, all I had messed up there was I had the 32 for n, which of course we know is silliness because I had n equals 13 here, and my sum is 32. That's what I'm after. So I got 2 times t1 minus 72. I'm not remaking this video because of that mistake. That's silliness. So now I can use this to solve. So let's see if I can't work this out. So I'm going to have 64 on this side divided by 13, which is probably not going to be that lovely of a number, but anyway. 2 t1 minus 72. So I just multiplied that by the 2, so I cross multiplied. I got 64, and then I divided it by 13. 64 divided by 13 is not fun. But anyway, we'll leave it as is, I guess. And then I gotta add 72 to both sides. So I'm keeping this in my calculator. And if you saw the calculator I'm using right now, then you'd be kind of embarrassed for me. Plus 72. And then I'm going to divide it by 2. So my T1 is, my calculator gives me an approximate number, but if you had a TI-83, which I don't have at the moment, you might be able to get a good fraction, which is going to be 38 we'll go with 5. So my first term is 38.5. So let me just check this over to make sure I didn't make any mistakes here. So I think we're in business. I think this is okay. So again, we could kind of check this if we wanted to, and just run through the formula and see if we can get using that as my first term and seeing if we can't find if it works out or not. But I'm not going to waste my time doing that. You guys can have a look at it after. Alright, let's do one more question and then we'll be done. Alright, in an arithmetic sequence, T1 is equal to 6 and T9 is equal to 108. Find the common difference and the sum of the first 20 terms. So essentially we have the situation going on. We have 6 and then we have a bunch of blanks. So this is the first one. 2, 3, 4, 5, 6, 7, 8, 9, and that ninth guy is 108. So I need to find the common difference first. So that's what question's asking me. I need to find the common difference. Well, I know if I were going to subtract these, all right, 1, 2, 3, 4, 5, 6, 7, 8. I'd have to subtract it 8 times to get a common difference. So essentially what that's saying is that the difference between these two numbers is spread through here 8 times. So 108, I keep wanting to write 180. 108 subtract 6 is of course 102. And I did it again. 102. This video is a mock, by the way. 102. And that 102 is spread out 8 times throughout here. So 102 divided by 8, which I think is about 12.75. Or is exactly 12.75. So that's my common difference. That's what brings me up to here. So essentially I have 12.75 here, 12.75 here, 8 times, and that'll bring me up to 108 if I added all that together. So that gives me my common difference. Now the question is, how does that help me find my, my sum of the first 20 terms? Well, what I need to do now is I need to create T of n. Well, T of n is going to be equal to my first term 6 plus my common difference of 12.75 times n minus 1. So that's going to bring me to 6 plus 12.75 n minus 12.75. So essentially what I'm going to have, I'm going to have 12.75 n, and then I cannot afford to make any more mistakes in this video, so I'm not going to risk it. I'm going to actually do this on my calculator. And of course, it's something very straightforward. Negative 6.75 T of n right here. So there we go. So that's my T of n. Now, using that, I can find my last term. So if I know what I have now is I have my first term T1. I have number of terms, which is 20. I just need my T20 to be able to find my sum. So T20, of course, is just going to be 12.75 times 20 minus 6.75. So 12.75 times 20 is 255 minus 6.75. So we're looking at 248.25 for my T of n. So my last term of the sequence is that. So now we have everything we need to know to be able to find the sum of 20. So I got 20 over 2. First term is 1 plus last term 248.25. So I'm just going to do this all. So I got 10 times 249.25 or 2,492.5. So that's the sum of my first 20 terms right there. So, that's a little bit of a complicated problem, but you know what? It still relies on everything we know. There's nothing there that you guys didn't know. common difference, general term, everything there you guys know. You just have to practice these things and learn how to recruit them from all your previous stuff that we've done. So hopefully this video didn't confuse you too much with all the mistakes I'm making. But if there's any questions, guys, please see me in class or feel free to ask me. I hope this helped. But again, you got to study. You got to do questions. There's lots of them. All right, I'll see you in class. See ya.